Alright, in this video we'll be going over investigation 8.4.1. So this first question is asking, what do we remember about circles? We have some phrases here: circumference, diameter, radius. So if you don't remember, the radius is the distance from the center to the edge. Diameter is the distance across the circle. Right? You can think of diameter as splitting the circle in half. And the circumference is the distance around the circle. Some people also refer to this as the perimeter of the circle. So given this picture, can we highlight some of the parts? So let's highlight the radius in red. So from the center to the edge, that's the radius. Diameter cuts the circle in half. And the circumference goes all the way around the circle. So this outer edge, this green part, that's going to be the circumference. Okay. So how does a circle's circumference compare to its radius? Notice that if the radius is over here, it fits half of the diameter. So you see how the radius overlaps half of the space of the diameter? So you can think of this in two ways. The radius is half the diameter, or you can think of it as the diameter is twice the radius, right? Do you see how it fits inside half of it? It takes two of these radiuses, or two radii, to fit inside the diameter. Okay, so given these, let's go and figure out. So if the radius is 5, here, the diameter is going to be twice the length. You see it takes two of those red lines to fill the blue space, 10. Here, if the diameter is 22, notice that half of that, the red spot, is going to be 11. And here, if the radius is 7.5, again, the red part is only half of it. It takes two of them to fill out the diameter. So this would be 15. Okay, so our focus question is, what is pi, circumference, and the area of a circle? So here, this green line is going to represent the circumference, and this blue line is going to represent the diameter. Okay, and if I move the point, notice that the circumference, the outside circle, do you see how it's being laid out? So you can think of this as we're laying out the circumference. We're uncoiling the circumference. So you can think of it like a piece of string. If I wrapped a string around the circle and I unwound it, this is still going to be the same length, even though I made it a straight line. So again, it's still the space around the circle. I just straightened it out a little bit. So with that, how many diameters fill along the circumference? So this blue line is the diameter. And if I roll this out, let's see, 1, 2, 3. And if I zoom in a little bit, looks like a little bit more than 3, right? So it looks like a little bit more than 3 diameters fit. Okay. Let's try making circles of different size. So here I can grab this green dot to make it bigger. And notice that when I roll out its circumference, its perimeter, 1, 2, 3, it always takes a little bit more. Even if I made a bigger circle and rolled it out, notice that again, 1, 2, 3 diameters and a little bit more, right? It always takes a little bit more than 3 diameters to fit. So let's go and zoom in. So notice that again, it takes a little bit more than 3 diameters to fit across the circumference. So let's zoom in. So 3.1. Zoom in some more, 3.14. Zoom in some more, 3.41. Notice that it's halfway, about 3.145. And so if I kept zooming in and in, I'll be closer to 3.1415. Hopefully this number seems familiar because this is called pi. So pi is 3.1415. And how does pi relate to the circumference? So the circumference equals diameter times pi, right? It takes a little bit more than 3 diameters to fit along the circumference, or the outside. Okay, so that's what pi is. Pi is a little bit more than 3 because it takes a little bit more than 3 diameters to wrap around the circle. So keeping that in mind. So if this diameter is 5, what's the circumference? So let's see, here's 1, 2, 3. So let's roll it out. So this is the circumference. And notice that 1, 2, 3. It's a little more than 3 times, right? The circumference is a little bit more than 15. So again, if I did 5 times 3, that doesn't quite reach all the way around. It needs to be 5 times pi, right? Pi is 3.14. 5 times 3.14. That's how we get close to the reach the length of the circumference. Okay. Here, diameter is 7. So if I uncurl it, right, do you see 7 times 2 times 3? 3 times 7 isn't quite enough. We need a little bit more. We need 7 times pi, right? Pi is a little bit more than 3, and we need a little bit more than 3 to fit along the circumference. Okay. Here, this has a diameter of 2.5, so let's roll this out. So times 2 times 3. Notice that 3 times the diameter isn't enough. We need the diameter times pi, right? Pi is a little bit more than 3, and we need a little bit more than 3 to fit across the circumference. Okay, and here we know the radius is 2. So if the radius is 2, notice that the diameter is actually 4. So radius is 2, diameter is 4. So we need 4 pi to fit across. So 1, 2, 3. So again, if I doubled it, 8, 12 is a little bit more than 12. So I need a little bit more than 3. Right. For section C, we're going to be going over a proof for the area of a circle. So notice that these circles all represent the areas. This is the inside of the circle. And just like with the perimeter, I can unwrap each section of the area and corner it to make it a straight line. So even though I unwrapped it, do the colors still represent the area? Yes. It's the same space inside of a circle. Okay. So if I unwrap the circle, right? Unwrapped it. What shape is it coming closer to? It's starting to look like a triangle, right? Right now, there aren't that many sections, but again, if I increase the partitions, if I made it each one smaller, 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 do you see how it gets closer and closer to looking like a triangle? So again, here's a circle. Oh, I unwrapped it. So again, if I take all the layers of a circle and I unwrapped it, uncurled it, it should be closer to becoming a triangle. So if I find the area of the triangle, it would be the same thing as finding the area of this circle. So what's the base of the triangle? The base is going to be the circumference. Do you see how the outer ring, the circumference, if I unwrap that, it becomes the base. And here at the circle, the height is the radius. So here's the middle to the edge. And if I uncurl it, that becomes the height of my triangle. So if the triangle is 1/2 base times height, right? If I replace the base with diameter pi, and I replace height with radius, right? I can simplify it a little bit further. Diameter is 2 radiuses. Okay. Notice that the 1/2 and 2 are going to cancel out, and r times r is r squared, so this becomes pi r squared, which is our traditional formula for an area of a circle. So here, section D is going to be a different proof. So this proof involves rearranging it into a triangle, but we can rearrange the circle into different shapes as well. So here, these sections represent the area of a circle, and these sections can be rearranged to form a rectangle. So notice that I can rearrange it and slide it down. And it doesn't quite look like a rectangle yet, but again, if I increase the number of partitions, if I keep increasing it, again, if I slide it back, so I'm dividing the circle into smaller sections. I'm cutting it in half and sliding these down. As I increase the more partitions, notice that it's getting closer and closer to being a rectangle. So let's click on the parts and see. So here, this is the circumference, right? So the outer circle is the circumference, right? So if the circumference lasts this length, the base of the rectangle is about 1/2 of the circumference. And the height of the rectangle is going to be the radius. So area is base times height, in this case 1/2 circumference times height. I can rearrange circumference to write it as area equals 1/2 2 pi r times r. And notice that the 1/2 and 2 are going to cancel out. R times r is going to become r squared. So area equals pi r squared. So these are two different proofs to show what the area of a circle is. Again, over here, this is pi r squared. And here, when we turn it into a rectangle, it's also pi r squared. So by changing it into a shape that we know and finding the area, we can figure out the area of a circle. So now that we know the area is pi r squared, all right, let's go and answer these questions. Radius is 3. I'm just going to replace r with 3. So 3 squared is 28.27. Or we can do 3 times 3 is 9 pi. That also works too. Okay, so area is pi r squared. And if the radius is 7, I'm going to replace r with 7. Right? Or we can think 7 squared, that can be 49. Right? That would be the same answer. Right here, I know area is pi r squared. So this one's a little bit tricky. Here we know the diameter is 12, but the formula only works for radius. So I will look at half of the length. The radius is actually 6. So it would be pi 6 squared, or 6 squared can be written as pi 36. Okay. So what is pi? Pi is how many times the diameter fits around the circle. Circumference is the perimeter of a circle, and area is the space inside of a circle. All right. Hope you found that video useful, and if you still have questions, let me know.